Dear students, welcome to my channel Knowledge Hub. I am Dr.NH. In this class, we are going to discuss electrochemistry part 3. I have already released 2 videos on electrochemistry subject, part 1 and part 2. You can go and see that one. So, in this class today, we begin with electrolytic cell. How to purify an impure metal to pure metal. We take the example of copper. So we take the impure copper as anode and pure copper as cathode, and the medium is copper sulfate. So when you pass the electricity, DC current, and then this copper at the anode, which is impure, get oxidized to Cu2 plus, and it goes and deposits at the cathode by taking 2 electron and getting itself deposited there, means reduction. So this process continues until we get a satisfactory collection of the pure metal at the cathode. Here in this case is a copper. So similarly we can purify sodium, magnesium and aluminum. In the case of sodium and magnesium, we take fused chlorides, and in the case of aluminum we take fused aluminum oxide in the presence of cryolite. Hope you understood this. Dear students, next we will see the quantitative aspect of electrolysis, and that is defined by Faraday. Faraday postulated 2 laws. First law says the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. So the amount of chemical reaction depends on the quantity of electricity passed through the solution. So the amount of chemical reaction occurs depends on or proportional to the quantity of electricity passed through the electrolyte. Second law says the amounts of different substances liberated. Okay, now we can take sodium or electrolysis of sodium, magnesium, copper, whatever it may be. So the amounts of different substances, they are liberated by the same quantity of electricity. In all the cases, quantity of electricity is same. So passed through the electrolytic solution are proportional to their equivalent weights. I will read once again. The amounts of different substances liberated by the same quantity of electricity passing through the electrolytic solution are proportional to their equivalent weights. Okay. So the amounts of different substances related is proportional to their equivalent weight. Okay. For the same quantity of electricity. Okay. What is equivalent weight? So sodium releases 1 electron, right? So the equivalent weight of sodium is atomic mass of sodium, that is 23 divided by 1, because it releases 1 electron. If it is magnesium, okay, Mg, it releases 2 electrons. So Mg, atomic mass of magnesium divided by 2. So that is the meaning here. So the second law again says, I read, the amounts of different substances liberated by the same quantity of electricity passing through the electrolytic solutions are proportional to their equivalent weights. So we may use different chemicals, and the amount released for the same quantity of electricity depends on their equivalent weight. Sodium means atomic mass divided by 1, magnesium atomic mass divided by 2. So that is the equivalent weight. Hope you understood this Faraday's law. Dear students, now we can see what is 1 Faraday. That is charge on 1 mole of electrons. Charge on 1 electron is equal to 1.6021 in 10 power minus 19 C. Charge on 1 mole of electron is equal to, multiply this factor by 1 mole, 6.02 into 10 power 23 per mole, this one. So when you multiply this, you get 96,487 C per mole. So that is approximately 1 farad is equal to 96,500 C per mole. So that is applicable to where one electron is involved in a reaction like Ag plus aqueous plus one electron, that is metal get reduced to Ag. In case of Mg2 plus, where 2 moles of electrons are involved, and in case of aluminium 3 plus, 3 moles of electrons are involved. Hope you understood what is Faraday. Dear students, now let us see a problem. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at the cathode? This is the question. The solution. We have run the current for 10 minutes, which is equal to 600 seconds. The charge, now current into time. The formula for charge is equal to current I into time, which is equal to the current is 1.5 amperes into 600 seconds. That is equal to 900 C. That is the charge for 600 seconds. That is for 10 minutes. Now for 1 mole of copper to reduce, which is, we need 2 faradays of charge, 2 into 96487 C, to deposit 63 gram of copper. And we have only 900 degree charge, 900 C charge. So then we have to divide 2 faradays, 63 divided by 2 faradays into 900 charge. So this is the total charge for 1 mole of copper, but for 900 charge we get 0.2938 gram. So for 10 minutes if you run the solution, we get only 0.2938 gram deposited at the cathode. Hope you understood. Dear students, now we will see product of electrolysis. We take the case of aqueous sodium chloride. Normally when you put sodium chloride in water, it will dissociate into sodium plus and Cl minus ions. So then we will see during passing of the current, what are the reactions that is possible at cathode and anode. Okay, if you take the reaction at the cathode, water will dissociate and give hydrogen gas and OH minus by taking electron. The expansion of this reaction is H2 liquid giving H plus OH minus. This H plus taking one electron becoming half gas. So this is the expansion of this one. So this is the reaction at the cathode. And anode, there are 2 reactions possible. I will write one reaction here. Cl minus aqueous giving half chlorine gas plus electron, and the E0 cell of this reaction is 1.36 volt. Now come here. The another reaction at the anode possible is the water dissociating to give O2 gas, 4H plus and 4 electron. E0 cell of this reaction is 1.23 volt. But this reaction will not happen because of over potential of the oxygen. So this will not happen. Only this reaction, chlorine giving chlorine gas, electron minus. So the next reaction, if you take add 1, 2 and 3, you get NaCl aqueous plus H2O liquid giving Na plus aqueous plus OH minus aqueous plus half hydrogen gas plus half chlorine gas. Hope you understood this. Dear students, we will see batteries. Batteries of 2 types, primary batteries and secondary batteries. Primary batteries are mainly they are dry batteries. What we use in the remote, in clock, in torches, etc. This type, where cathode is a carbon rod or it is made of graphite, and the anode is the cup which is made of zinc, and in between they fill manganese dioxide, carbon black and ammonium chloride paste. So once you start using it, the reaction takes place and the current is liberated due to this redox reaction. And after that, this battery, when we start using it, after some time it will die automatically. So we cannot recharge or anything. So it's a total volt 1.5. This battery will give 1.5 volt. So the reaction at the anode is zinc gets oxidized to Zn plus 2 electron, and cathode it is getting reduced from MnO2 4 plus ammonia N plus electron. Then it forms a complex MnO within bracket OH plus ammonia. This ammonia reacts with zinc Zn plus and it forms a zinc tetramine 2 plus ion. Okay, zinc or tetramine zinc 2 plus ion. It forms like that. So this is a dry cell. We will see another dry cell which is usually in the watches and other things. Small round you would have seen them, no? And the car remote and all you will find. That we will see next. Okay, hope you understood this. Dear students, now we will see dry battery in which we see now mercury cell. This mercury cell is something like a button type battery which you can see in watches, remotes and calculators, etc. So I will try to give a picture, but I think I am not good at the picture and you can understand. So this is the button type of battery, dry cell battery. It gives 1.35 volt. This anode is a cap. Okay, so which is zinc amalgam, made of zinc amalgam, and the cathode is mercury oxide plus carbon. The electrolyte inside what they fill is potassium hydroxide and zinc oxide. So reducing agent is zinc. Okay, so oxidizing agent is mercuric oxide. So the reaction at the anode is zinc amalgam plus OH minus, we can take from that, gives zinc oxide plus water plus 2 electrons. The cathode, mercuric oxide plus water plus electron gives mercury 1 plus 2OH minus. The overall reaction is zinc amalgam plus mercury oxide solid gives zinc oxide solid plus mercury 1. Okay, the mercury from oxidation 2 to getting reduced to oxidation state 1. So the what we get from here is 1.35 volt. Okay, once it is consumed, the charge which is stored in the cell, then we have to throw this. So this is dry cell battery. These are also called mercury cell. Hope you understood. Okay, now we will see the lead storage batteries, which is a secondary battery. Okay, we have seen before primary battery, now secondary battery, and this is a construction of that battery. This is anode, this is cathode, and here you have the grids, lead grids filled with spongy lead, which is a negative plate, and this one is a positive plate that is filled with lead oxide. This is spongy, this is lead oxide, and the container contains 38% sulfuric acid solution. And the beauty is you can recharge these batteries. You must have seen this in the car batteries and also UPS at home, right? So this can be reversed. If the charge is finished, then we can reverse the current so that it will get charged. In car also, you know, we do the push. When the car is not starting and the battery is dead, we try to push and start that one. And or we connect another battery externally so that the car gets the current from that. Once that is current connected, then it will get even if it is discharged, it will start working. But if it is totally dead, we can have two options, either to replace with a new battery, or we go to the service center and give them, then they will reverse the current supply and then they will make it working. Means then you can start giving the current. So this is the benefit of lead storage battery. Anode is lead plus the sulfuric acid sulfate reacts to give lead sulfate into electron. Cathode, you got lead oxide and that reacts with SO4, the sulfuric acid, 2 minus 4H plus 2 electron gives lead sulfate. Both gives lead sulfate. This is the reaction. So overall reaction is lead oxide, which is solid, reacting with 2 moles of sulfuric acid gives lead sulfate solid 2 and 2 water liquid. So this is the simple arrangement. And you got another battery, what is called nickel cadmium, which is rechargeable, but in the book it is given, but not much discussion. So I will not be going to the details, because in the book itself it is not given in details. Hope you understood. Dear students, now we will discuss about fuel cells. Fuel cells are a green energy, and where we use hydrogen and oxygen, and hydrogen reacts at the anode and oxygen reacts at cathode. These are all platinum or palladium electrodes. They are impregnated, they are finely divided, and the medium is aqueous sodium hydroxide. The resultant product is water. So this is 70% efficient reaction. Whereas if you use this coal, oil and gas, fossil fuels, and we get efficiency of only 40%, here we get 70%. And the reaction at the cathode is, let us see, reaction with the anode is 2 hydrogen plus 4 oxygen, releasing 4 water and 4 electron. The 4 electron reacts with this oxygen and water and gives 4 OH minus. So this is cathode reaction, the anode reaction. The overall reaction is 2 hydrogen gas, oxygen gas gives 2 water molecules. And latest government of India is focusing on green energy, and we have seen one train was in operation using the hydrogen fuel, which is fabricated at the ICF factory Chennai. Hope you understood this fuel cell. Dear students, in the electrochemistry, the last chapter is corrosion. So we will see about the corrosion. The corrosion is mainly because of this Fe2O3, which is a red color. When it is formed on the surface of any iron material, red color powder, which means it is a corrosion. And because of the corrosion, the material gets destroyed. Even the bridges and other things will collapse. And if you see the cars and other things near the coastal area used to get corroded. Whatever you do, because of the moisture and atmospheric acidic nature, the metal used in the cars get corroded. These are the damages. So even the copper and brass will get a green color deposit. There is also corrosion product only. How this happens? Fe2O3 is the final product, which is a corrosive product. In atmosphere, we have oxygen and H plus. H plus comes from the carbonic acid. How carbonic acid? Atmosphere has got carbon dioxide. Because of the carbon dioxide, in the atmospheric moisture, it becomes carbonic acid. So it contributes H plus, and already atmosphere has oxygen. So that gives the water. This water and the iron 2 plus iron reacts in the presence of oxygen and gives rise to Fe2 plus. So this is the overall reaction. This Fe2 plus is not stable, so it will again react with water and oxygen. It takes a required amount of oxygen and form Fe2O3. This is the final stable product, and this is the responsible for corrosion. So we have to protect the materials from corrosion. For that, we use the techniques like painting, or we galvanize with zinc or tin. Hope you understood. With this, chapter on electrochemistry is coming to end. Thanks for watching.